Be careful before you try to do this limit, not to fall in the mistake of doing this, right? Because this is not true. This is only true when x goes to 0, because then x cubed goes to 0. But this is not the limit we're dealing with. We're dealing with x to infinity. So this is useless here. Actually, this sign here, all you can say when x goes to infinity is that the sign is in between 1 and minus 1. But actually, there's no limit for this expression, right? Okay, so we'll ignore this, okay? And what we're going to do is, right, this is something that is between minus 1 and 1, whatever the argument here. However, this is something that goes to infinity. So this is the leading term of the expression in the numerator, so we are going to factor it out as in the previous case. So we have x here, and then we have 1 plus, and here we have sine x cubed over x. And in the denominator, well, it's easy, factoring out x, right? You get 5 plus 6. Plus 6 divided by x. All right. Now the sine of x cubed divided by x is something that you calculate. The limit of that when x goes to infinity is something that you calculate because, as I said, this is bounded by minus 1 and 1 despite the argument that you have here. So if you divide by x, the whole expression, what you have is this. Sine of x cubed divided by x and smaller than 1 over x. If x goes to infinity, then this goes to 0, and this one goes to 0 too, right? So by the sandwich, the limit of the sine of x cubed divided by x when x goes to infinity is equal to 0. So we don't need to worry about this, because the limit of this is 0. The x, by the way, cancels. The limit of this is also 0, so this numerator goes to 1, this goes to 5. So the limit of this expression is just 1 divided by 5.